manipulator arms. So we have a robot which is composed of 3 arms in series, such as in the picture. So they have different length. For instance, the first one, this one has a length equal to 3. So the second one to 2, and the last one to 1. So this robot has 3 degrees of freedom. So alpha 1, alpha 2, alpha 3, where each alpha corresponds to an angle. So for the basic sketch, we'll choose a cube, and from the cube we'll have to do rotating arms, such as in the picture. So here I represented a picture with a rotating arm. We can understand that here we have X, Y, and Z like this. The first angle, alpha 1, corresponds to this one, and alpha 1 corresponds to rotation with respect to Z. Now we also have the second one rotating around the first one, also with respect to Z. So if you prefer, these 2 arms, this one and this one, so arms 1 and 2, are in the plane X and Y. Okay. And the last one is the angle alpha 3, where I rotate with respect to Y. So it rotates on itself. Again, the 3 arms are all on the plane X and Y. Okay. And for this I will start from the unique cube, and the unique cube is here. I have here X, here Y, and Z. And here I have 1 here, 1 and 1 also. So for this I will have to build a matrix sketch to represent these cubes, and then I will apply some linear or affine transformation. So what I will do first, I will propose a Python program that will draw my cube. So it is the following. Here I define my unique cube. So this one U corresponds to this cube, U, and here I have the sketch with 0, 1, so it corresponds to each vertex. So I should, for instance, this one corresponds to this vertex, this one to this vertex, and so on. And if I, with my pen, if I draw, I go from one vertex to another, then I will be able to draw the whole cube without lifting the pen. Okay, so it is the definition of a sketch. So I draw the figure, I open it, I draw the axis here. So red, green, blue. And then I will draw in homogeneous coordinate, because here, since I have only ones, I have 4 lines, and it corresponds to homogeneous coordinates. So I will draw with 3 like 3 dimension, H like homogeneous. I will draw U. I go here, I run, and this is my cube. I can rotate like this, and I see the cube defined by U. Now from this I will perform some transformation, and the first one, for instance, will be a translation with respect to -0.5, -0.5, so that I will be able to recenter the origin on the center of one face of the cube. So it will make the picture more realistic. So I do this. So this corresponds to a translation by a vector 0, minus 0.5, minus 0.5. If I do this, I will obtain the cube here, the green cube, and we can understand that the center of the face of the green cube after the translation is origin. Okay, we can see better view like here. Okay, and now to build one arm, I will have to perform some kind of diagonal transformation so that I can increase the size of one length and reduce some others. So that's what I will do. I come back here, and from S0, so the shifted cube, I will perform some diagonal transformation. So I multiply by 3 the length with respect to x, and I will multiply by 0.3, so I will decrease the size with respect to x and y. Excuse me, x and z. And the one here is to have due to the homogeneous coordinates. So from the unit sketch, the unit cube, I made a translation and I obtained a new matrix here. And again here, after diagonal transformation, I will perform change the size of my cube. So if I run it, I can see here the initial cube U red, the shifted cube after the translation green, and after I change the size and I obtain the blue one. And the blue one corresponds to one of the arm I am supposed to build with a size, with a length equal to 3. For the rotation, I start from the unit cube, so represented by this matrix, which is a sketch. And the sketch I will have to rotate and translate. So for the rotating, I use the function which is called rot of w, which corresponds to this formula, which is a Rodriguez formula, which say that if I want in homogeneous coordinate, if I want to rotate around omega like this with an angle of norm of omega, I should build this matrix. So omega is omega x, omega y, omega z, the coordinates. Then I build the exponential matrix of this skew symmetric matrix. I add 3 0 here, 3 0 here, 1 1 here, and this corresponds to my rotation matrix. If I multiply this by this will make the cube rotate. For the translation, it's something similar, but if I want to translate by v equal to v1, v2, v3, I take this matrix and I will multiply the sketch by this matrix. So what I want to do here is to rotate the cube. So once I have transformed, to rotate the cube around z. So here I have x and y. Recall that I have already built the arm of length 3. The length is 3, with here 0.3, and I want to perform a rotation like this. To do this, I will adapt my previous Python program, where I can see here the unit cube, the transformation to build my arm, first the translation, then here from this translated cube, I will build my arm by this multiplication. So this corresponds to the matrix 3, 0.3, 0.3, 1, which from U will adapt the size of my cube. Then I will rotate it by an angle 0, 0 to t, so this corresponds to the z component, so that my arm will turn like this with a rotation speed of 2. This is why, because I have an angle of 2t. And I will draw this transform sketch in blue. So that is what I will do here. Correspond to this program. I run it. I can see the rotation around the z-axis. Okay, not that for this I use Autolib library, and on the Autolib library I can see here the translation like this in homogeneous coordinate, where I can recognize x, y, and z as a vector toward which I want to translate, and the one due here to homogeneous coordinate. For the rotation is similar. I use the exponential of the skew-symmetric matrix, and adjoint returns me the skew-diametric matrix associated to the vector omega. Okay, so this function is here. Just add 0 and 1 to transform a 3 3 rotation matrix into homogeneous coordinates. So 2h means 2 homogeneous. What I have done for the first cube, for the arm 1, I started from the unit cube. I changed the length of the cubes, and I rotated with respect to z here. Now, for the second arm, what I will have to do, I also start from the unit cube. I give the good dimension. So here the length is 2 only, so it will correspond to this. Green. The length is 2. 2 like here. Then I will have this small one to rotate by an angle alpha 2. So let's say I will put it, I don't know, like this. Not the same angle, so it's alpha 2 only. I rotate by alpha 2. Then I translate to put exactly of 3, 0, 0 to put exactly here. Okay, and now I will apply exactly the same transformation as the arm 1. So this, they are connected, the two of them. So it means since it will receive exactly this transformation, then it will go here. Difficult to represent. Okay, so it will go here. The same rotation, alpha 1. So it is what I will do. And alpha 1 will move with t, so I took alpha 1 to t, so for alpha 2 I will take, for instance, minus 4t. It means that it will not turn in the same direction as alpha 1. So for this I take the following Python program. So recall that I have my unit cube here, my unit cube here, translation to center it, then I add alpha 1, alpha 2, so 2t here, minus 4t here, just to make the angle change in the loop. For the first one, it receives the transformation described here. And for the last one, first I have changed my size. I rotate by alpha 2, and then I will put it at the extremity of the first arm, and to make exactly the same transformation as the arm number 1. And I will blue it green, whereas the arm number 1 is painted blue. This is my Python program. I will run it. I can see here the blue and the green. For the arm number 3, then I will exactly follow the same reasoning as previously. So it means, recall that the arm 1 has had this rotation. So the arm number 2, which has been connected to arm number 1, also receives the same rotation. Okay, now the arm number 2 had received this rotation. So it means that the arm number 3, which will be connected to the arm number 2, will receive exactly the same rotation. But it have also its own rotation. So you will have, first, I will change the size to make a length equal to 1. I will rotate with respect to alpha 3, but now with respect to the x-axis. I will translate of 2, why 2? Because it is the size of the arm number 2, and I have to put at the extremity of this arm. The same was before, when the arm number 2 had to receive a translation of 3 due to the fact that the length number 1 was equal to 3. So these transformations are described in the Python program given here. Again here, my cube U, unit cube. I translate it to center the face. Here it corresponds to the sketch number 1, to the arm number 1 if you prefer. Here is the sketch number 2 of the arm number 2, and the same for the 3. So we can recognize here this matrix, which is diagonal, which makes me possible to obtain the right size. Then the rotation with respect to the x-axis of alpha 3, as given here. The translation to go at the extremity of the arm number 2. And then exactly the same transformation here that was already made by the arm number 2. Okay. I switch to Python. I take my program. I run it. And I can see the black cube corresponding to the arm number 3 rotating on itself. So here alpha 1, alpha 2 here, and alpha 3 like this. So I can change, just to have a better understanding, I can change the size. For instance here, I can put 1 like this. just to recognize the it will change the size of the arm number 3. I will unrun it. And I see that indeed so I can have a better view of the rotation of the arm number 3.